Okay, Kira had the question of when do things have to be in for the various courses, and my answer was as soon as possible. Okay, especially for the three of you in this class I know are graduating, Kira, Jesus, and James. I think all three are graduating this term. Get me your stuff just as soon as you can, so I can get it graded just as soon as I can, because your grades have to be in. I'm guessing it's probably the Wednesday of next week, even before finals are over with, because I have a mini-term physical science class. I don't know if any of those students, it seems like one or two of them are graduating, and their last day of class is Tuesday and don't have the final until Thursday, and I'm supposed to have the grades in on Wednesday. So I'm just going to have to ask them to do their finals very quickly, okay, so I can get them in. But I don't think it's a big deal, because if you're going through the ceremony, you're going through the ceremony, okay? If you don't finish, and this won't pertain to you, but other students, if they haven't finished something, they're not going to actually get it, because the ceremony is virtual anyway. There's no diploma that really is being passed out. It's just the ceremony. And if they don't finish their work, they really didn't graduate. They just went through the ceremony. So I don't think it's a big deal. So I'm not going to worry about it too much, but just get me, to answer Kira's question, just get me your work as soon as you can. Research papers, old tests, whatever, get them in just as soon as you can. And I'll grade them as soon as I can and try to have the grades out there. I'm guessing it's by Wednesday. I don't know if that's exactly it, but I'm going to try to have graduating students in by Wednesday, if at all possible. All right, everybody else, your grades are going to be due in noon the following Tuesday. The week after finals are over with, that's when your grades are going to be due in. I'm going to try to get those done sooner as well. But anyway, that's where we set. Now, I'll ask you again, any other questions? Okay. Again, today it's just me and Kara. I don't know where the rest of you students are. I know that Jemanuel had I think a death in the family, that he couldn't be here on Monday, and but he was here this morning for his Cal 3 class, so I was thinking he would be back here now. And James was here this morning, though he was having trouble staying in. And now I haven't seen or heard from Jesus recently. Kira, do you know where Jesus, his original home was? Would it have been Puerto Rico, or do you know? Okay, because I did have a couple of phone calls from Puerto Rico, and I thought, I don't know anyone in Puerto Rico, so I didn't answer them. And then later, okay, but he didn't have to go home to Puerto Rico for some reason that you know of. Okay, so he's still around. Okay, I was afraid I had missed his phone call, but he had been a very, very, very good attender, and suddenly toward the end here, I haven't seen him, and I was, number one, afraid he might have COVID or have been, well, I don't know. And number two, then I got to worrying that maybe he had to go home to Puerto Rico for some reason, because I got those two phone calls. So that makes me feel better. Hopefully he'll be following this on YouTube videos. Okay, so let's go on and pick up where okay, here's James. Good. We spent enough time talking that James finally got here. So we doubled the class size now. Way to go, James. Okay. And so we got number 1 and number 3 here. We don't have any of the evens or number 5. So, James, the questions were earlier, when does things have to be in? And especially for you, Kira, and Jesus, just as soon as you can get them to me. So if you have any research papers out, I think you've turned in both, all of yours. If you have any tests out, and I'm pretty sure you've got most of those in, if you got anything else, just get them into me as soon as you can. And then I'll.
I just got one more test to put that linear algebra 3 on.
Right.
Do we have a final exam?
Yeah, there will be a final exam. It'll be very short, just based on as far as we got in the course. And we're in chapter 4, and we didn't get all that far in chapter 4, so it'll be a fairly short test. There'll be questions on it that'll be optional, just like there were. I don't know. I don't think you made it into the end of class on Cal 3, but I showed the final exam, and I think the first 9 questions you can do. The 10th one will be totally optional. It'll be bonus if you get it right. It won't count against you if you skip it or get it wrong. So that's how it'll be in linear algebra 2, and probably in this course as well. Okay. I've already got tests made out. I had to have them made out. I didn't know how far we'd be getting. So I'll go at the end of the class today. I'll show you the test, and then sometime after class ends, I'll be posting it on Blackboard. And I'll post it, always put it on Blackboard messages, and I'll probably also try to post it under, there is a tab after the weekly activities, and one of the last tabs out there in the homepage of Blackboard that says exams, midterm, and final. Now, we didn't have a midterm, or all the other tests were midterms, but I didn't post them there. But it'll be the final exam, and in that, if they left me a place that I could put it, they were supposed to leave a little plus sign in a circle, and if they did, I can post it there. If they forgot to do that, then it'll just be posted on Blackboard messages. Okay, so but it'll be 2 places. I'll show you what the exam looks like. I'll tell you which questions are required and which ones are optional, and then and we'll do that right at the end of class. Okay. And if you watch the YouTube video, for if you weren't there at the end of Cal 3 this morning, when I finally get that loaded, and that's probably going to be tonight before I'll finally get that on the playlist, but you'll see it there. But by then, well, you can be working on the test until you see that, and you'll see which questions are optional. Number 10 is optional on Cal 3 test. Now, on the linear algebra, I'll be doing the same thing. We'll get as far as we can tomorrow in class, and then I'll show you the test and tell you these questions are required, these are optional. Okay. Does that sound okay? And then just get me your test. The past test, get me as soon as you can. The other tests, get me really as soon as you can too, but I will need those. I'm guessing now, James, have you heard when your grades have to be in? Are you going through graduation? Virtual? Okay, I don't get an answer there. So anyway, let's pick up and go from where we left off last time. Let me get screen share set up. I'll get the book set up. I'll try to get the book set up. Yeah, there. Okay. All right. And let me get this thing moved out of the way. You can't see it, but it's a big old taskbar that sits in the viewing area. I'll get y'all moved over to the right as far as I can. And actually for this, I'm going to move you up. But let me get the whiteboard set up first, because we will be using that. So it'll be already set up. Let me get its taskbar, which they put right in the top. So I can't write there. And then I'll move the whiteboard over as far as I can to the left and up, though you probably can't see I'm doing a thing. And let's go back to the textbook. Okay, now for the textbook, I'm going to move y'all to the top. Okay. Any questions on anything we've done so far? All right. Now, last time, Kira was the only one here, but we got down and we're working on example 3. Okay, we're in chapter 4, higher order differential equations, section 4.4, undetermined coefficients, the superposition approach. And that's the only approach we're going to do. They recommend you either do 4.4 or 4.5. I've taught it both ways, and it seems like students pick it up better on their superposition. So we didn't do annihilator approach, even though some of you may be Arnold Schwarzenegger fans, but we're not doing that. We are doing the superposition approach because we've already done that in some. So we got down to this line right here. This was our original equation, y double prime minus 2y prime plus minus 3y. That's your left-hand side with all the y's in it. Your right-hand side, which has all the x's in it, 4x minus 5 plus 6x e to the 2x. Okay? To solve that differential equation, you first do the associated homogeneous equation. In other words, you set the right-hand side equal to 0. There they did it. And you come up with the complementary solution. And that's the one for the left-hand side alone equals 0, the homogeneous case. And that's always going to be when you have linear differential equations, constant coefficients, you will be in the your characteristic or your complementary solution will be of the form second order differential equation. You'll have two arbitrary constants, C1, C2, and one of these will go with one of the e's you find here, and the other will go with the other e. And how we get those e's are to set this, assume that your solution is y is equal to e to the mx, set this up as m squared minus 2m minus 3. This one you could factor. If you can't factor, use quadratic formula. If the quadratic formula comes out real numbers, use them. If it comes out a single real number, you'll need to do the case 2 that we did back in 4.3. And if they come out complex numbers with imaginary parts to them, then you'll need to use sines and cosines, not e's exponentials. These came out with factors of -1 and +3, not factors, solutions of -1 and +3 when you did that m equation here, m polynomial, quadratic polynomial. You got those two values for m, plug those in here. That's your complementary solution. Now you deal with the particular solution. That's the right-hand side. Okay? Because you have a polynomial expression here, then your first guess at your polynomial will be ax plus b. Okay, looks a lot like this one, but you have to include any terms that may be missing here, you have to include down here. For this next term here, is a polynomial times an exponential. Well, the exponential is going to take care of itself as an e to the 2x. That's the only thing that will produce an e to the 2x. But this one you'll need another ax plus b, because you have to, even though this doesn't have a plus c with it, or plus some number with it, you have to have another one. So, except not ax plus b, cx plus, and the book doesn't like to use d, so they jump to e. So the polynomial part alone, 4x minus 5, will produce a ax plus b as your educated guess. The 6x e to the 2x will be a cx plus e times e to the 2x, which would be a cx e to the 2x plus e e to the 2x. Now that's one reason I don't like to use e, because you got an exponential following it, you know. So you're saying EE, and one of them's a capital E constant, the other's your exponential function. Okay, with this being your particular solution, at least your best guess at one, then you take that particular solution, take its first derivative for here and its second derivative for there. So that's where we got to last time. When you took the first derivative of this, you got a, and then you had two terms from here and a term from there. And then when you took the second derivative, the a disappeared, derivative of a constant of 0, and you had two terms from the first term here, from one of the terms here. Now, I don't know why it makes those noises, but it does, and I don't see anybody else coming in, so whatever. So you take the second derivative of this as well, capturing all the terms, and then what you do is write that out with those first and second derivatives and the original function here. Write that out, and you know that differential equation with that that particular solution in it has to equal this. Okay. Write those terms out, and I think we had done these terms last time, and that's what I can't recall for sure, but let's just imagine that we had. I don't want to redo the wheel if we've already invented it, so we'll just write it down now. I'm going to the whiteboard now, and I'll go from that equation right there, and I'm going to move y'all back out of the way, because between the book and the whiteboard, it just keeps bouncing around here. Okay, so here's what we have. Y particular double prime minus 2 y particular prime minus 3 y particular. Okay, now we had already worked these things out, and here's what we came down with. From that y particular, and I probably should write that down. I'm not going to take the time to do it. Here's what we had. Minus 3ax. Okay, that came from the minus 3 times the y particular here. Okay, minus 2a, that came from your first derivative of your y particular. Minus 3b, that came from your y particular here. Minus 3, yuck, that erased my b. Minus 3c x e to the 2x. Okay, plus, now they group a bunch of terms together here, or two terms anyway, and that would be 2c minus 3e. I'll tell you, the 2c came from your first derivative of your y particular. Your minus 3e came from your minus 3 times your y particular. Okay, and that's times e to the 2x. All right, that accounted for all your terms there, and you know that has to equal to 4x minus 5 plus 6x e to the 2x, because that was your right hand side. And you know that when you do the y particular function, you have to account for that right-hand side. Okay, now I think I've got it all copied right. I sure hope so. And it really doesn't matter how you proceed with this as long as you proceed. Okay, now, and I was thinking we got some of this done, but maybe we didn't. Okay, the only linear term, x alone term that you have on the left-hand side is this one. Okay, the only x alone term you have on the left-hand side, on the right-hand side, is that one. So that basically tells you that minus 3a is equal to 4. No way around it. That's what it's got to be. That means a is equal to minus 4/3 if you divide both sides by minus 3. And my 3 disappeared. Okay, so we've got our first coefficient. Okay, now up here we've got two constant terms, and only two constant terms, minus 2a minus 3b. Okay, down here we only have one constant term, minus 5. But we already know what a is. A is minus 4/3. So if we put that in here, minus 2 times minus 4/3 would be 8/3. Okay, that's minus 2a. Minus 3b has to equal, and this one that I had a box around, the box disappeared, a negative 5. Okay, well, let's subtract 8/3 from both sides. And that gives us minus 3b is equal to, now minus 5 is minus 15/3, minus 8/3 is minus 23/3. Dividing this by negative 3, just putting that in the denominator here, that would give you b is equal to, the two minus signs go out, and this will be 23/9. Now I should be checking my answers and making sure I'm not making a dumb mistake somewhere. Yeah, a is equal to minus 4/3, got it. B is equal to 23/9, got it. Okay, now let's go back to this again. Here we have a term. If I could get the pen to move, there it goes. All right, this one I'll put in a circle type or an elliptical type thing. Here we have an x e to the 2x term. Here we have an x e to the 2x term. These coefficients have to be the same. So minus 3c has to equal 6. Minus 3c has to equal 6. Well, that's pretty simple to do. Divide both sides by minus 3, and you get c is equal to negative 2. Well, let's see if that's what they got. They did. Good for them. All right. And then, okay, and then, notice we don't have any more terms down here, and yet we have one up here that has an e to the 2x in it. Well, that says to me that 2c minus 3e has to equal 0. But we already know what c is. It's negative 2. So this says that minus 4, 2 times negative 2 is minus 4 minus 3e has to equal 0. So what I'm going to do is add 4 to both sides, and that gives me negative 3e is equal to 4 and e is equal to negative 4/3, which is the same as a, but that's okay. It's sort of unusual for that to be the case, but it's not impossible. They're perfectly good numbers. So, where does that leave us? Plugging these values in here, A, B, C, and E into the right-hand side here, into our particular solution, which I didn't write down, and combining that with our complementary solution, we then have our general solution. Okay, so y in general, and this pen is not writing well, is equal to the complementary solution C1 e to the, which one did they list first? Come on, where is it? We just had it up there. There it is. Let me get the book in my lap. It's hard to read from an angle. Okay. There it is. Okay, way up at the top. Okay, C1 e to the minus x, I thought that was the one they did first, minus x plus C2 e to the 3x. Now those are the only ones that have arbitrary coefficients. Okay, the particular solution have these what were undetermined coefficients. Now we've determined them. So we add to that the particular solution, which, if I can find my pen, is going to be plus, okay? No, it isn't. It's actually going to be a minus, okay? Yuck, all that effort to get the plus to right and then realize it's really just a minus because a is a negative, okay? All right. Okay. Your particular solution started, if you recall, ax, okay? And normally it would be plus ax, but a is right here negative, so this will be minus 4/3 x. Then the b was a plus 23/9. C was a minus, so minus 2, and that was your x e to the 2x. Now, I'm running out of room, so what I'm going to do is erase some stuff. Sort of wish I had done it earlier. We've already used our b, we've written it down, so I'm going to get rid of it now. Okay. Okay. Now, there was the c, minus 2, and then the e is a minus 4, minus 4/3. E to the 2x. Okay, that's our general solution for that differential equation. Okay, C1 e to the minus 3x plus C2 e to the 3x. Oh, my x disappeared. I hope I had it down there. Okay, minus 4/3 x plus 23/9 minus, now they combine both of these together and did minus 2x plus 4/3 e to the 2x. No reason to do that, but they just combine those two together. Minus 2x plus 4/3 times e to the 2x. Now, we did this by superposition, whether you realize it or not. That's what we did. So I think I'll go back to the textbook and continue the rest of the discussion here. Okay, so let's go back to the textbook. I'm sorry, folks. I barely got to eat half my lunch today. My first class, several issues came up, and I got to make a salad and take 3 bites before I had to come up. So my second class went over as well, and so when I went downstairs, I was able to finish the salad, make a sandwich, and take 3 bites. Okay, so I'm running a little low on fuel, so I'm going to, excuse me just a minute. As you know, ad nauseum, I'm anemic. So when I get low blood sugar, I feel it really distinctly. Okay, so let me move y'all out of the way. You can't see that, but I can. Okay, so here's what we did. There was our differential equation. We did the left-hand side and got the complementary solution. Then we dealt with the right-hand side, came up with 2 proposed sets of possible functional values to be your particular solution. Took the derivative and second derivative of that, plugged that into where you had yp's from this, our original side, and then wrote those in there. Okay. Now they rearranged them, but they're all here, and then that gave us this. Now from that identity, because those had to be exactly equal, and this is what we did. We found out A was equal to minus 4/3, B was equal to 23/9, C was equal to -2, and E was equal to minus 4/3 again. Okay, so this was our particular solution. No, that's not someone coming in, is it? It's just my dragging this across. Well, we doubled the class size from last time, but still, we're less than half the students here. Okay, so minus 4/3 x from there, plus 23/9 from there, minus 2 times x e to the 2x from there, and minus 4/3 e to the 2x from there. Okay, now, then we plugged in the general solution was the complementary solution plus the particular solution. That's the particular solution. Way up there had been the complementary solution. Add them together. That's it. In light of the superposition theorem principle that was back in 4.1.7, we can also approach example 3 from the viewpoint of solving 2 simpler problems. Okay, now this is redoing what we just did. You could have just done the first, I can't show it all on the screen. The first part of that for the polynomial part, and the second part here for the exponential part. Okay, and then just done them separately and then add them all together. yp1 plus yp2. We sort of did that anyway. So, I mean, there was nothing magical about doing them all at once or doing them separately. They all came out the same. Okay, now in the next example, okay, let's go back up here, and I want to point something out to you. Your complementary solution here had an e to the minus x and an e to the 3x. Your particular solution had an e to the 2x. No problem whatsoever. But what if your particular solution had either an e to the minus x in it or an e to the 3x in it? If either one of those would have happened, we would have been, I wanted to say in trouble. It's not really trouble, but it's a lot like what we did back in case 2 of the homogeneous case, when you have two solutions. Remember that when you had a double root or a triple root or whatever, a multiplicity of roots there, like e to the 3x and e to the 3x, you can't use them both. So the second one, you make it x e to the 3x. Well, that would have been the same thing here. If this e to the 2x would have turned out being an e to the 3x, say, then everywhere you had an x here, you make that an x squared. This you make an x. You bump it up by 1 so you don't conflict with this. Okay? That's the key, and that's what we're getting at next. The next example illustrates that sometimes the obvious assumption for the form of y sub p is not the correct assumption. Okay? Now here, they call it a glitch in the method. It's what I was just describing. It said find a particular solution of this one. They didn't say to do anything about the complementary solution. That's a problem, okay? Because you've got to do the complementary solution. In the earlier problem, we didn't. They just said do the they were just having you practice on that. And I'm sorry, I've got to have a bite of something to eat. I'm sorry, I hate to do this, but like I said, I only got about half my sandwich eaten. So sorry. I've been behind the 8-ball all day, it seems like. So hopefully that'll give me a little boost here. Even though they say find the particular solution, you still got to start with the complementary. So let's do it. Okay? Let's go to our whiteboard and write these down. Okay? Now I've got to move y'all back out of the way here. Gonna clear my drawings here. Does anyone need this a little longer? Okay. Now, this is example 4. I hadn't turned the page yet. Okay. Now, even though they say find a particular solution, you've got to take into account what is your complementary solution. Y double prime minus 5y plus 5y prime plus 4y is equal to 8 e to the x. Okay. Just a problem. Okay. Now, do your auxiliary equation first. Do the left-hand side homogeneous equation first. And that would be y double prime minus 5y prime plus 4y is equal to 0. Ignore that. Let's do the homogeneous first. The assumption here is that y is equal to e to the mx. That's always your assumption. Now, you can then write down what they call the auxiliary equation, which is the polynomial equation, m squared minus 5m plus 4 equals 0. That's because if you take the first derivative and the second derivative of this, second derivative will give you m squared, first derivative will give you an m, and then you have the same coefficients there, and because the e to the mx will never be 0, ever, never be 0, then that part will have to be 0. Well, now we see if we can factor that. Well, that does factor is m minus 4 times m minus 1. You can check that and see m times m is m squared. That's what we got. Minus m minus 4m is minus 5m plus 4. That works. So this indicates to you that m is equal to 4 or m is equal to 1. That's where the problem comes in. Up here, this form up here is e to the x, as if m were equal to 1. But you're fixed. Your complementary solution, y sub c, would then be c1 e to the 4x plus c2 e to the x. That's where the problem comes. Part of your complementary solution, which you've got to have there, is e to the x. Therefore, your particular solution can't be also an e to the x. You have to add an x in there, make it x e to the x. Okay? So that's where it comes. Your particular solution, y sub p, is equal to, now, you don't need to have an e to the x by itself. You can't, because you already got an e to the x by itself. So your particular solution is a x e to the x. Okay? Yuck, the sorry thing. Okay, that's it. You don't need any more terms. It's just an ax e to the x. If this had been an e to the 2x or an e minus x or anything else down here, all you would have needed up here was an ae to the x, okay, to correspond to that. But since this form and that form are the same, you have to introduce an extra x here. Okay, if this would have already had an x in it down here, then, which is be hard to imagine, then, well, it would be if that would have been, multiple roots, it could have been, and then you have to bump this up to x squared, okay? You can't have the same thing, the same form here as you have here. You have to have an extra x. Well, what do we do with this? We take derivatives. Y p prime is equal to, okay, first ax times the derivative of the second e to the x plus second times derivative of the first a e, goodness, this aggravates me, e to the x. Okay, y double prime of p is equal to, same thing we did before, a x e to the x x plus a e to the x, that both comes from this one, plus an a e to the x. So basically that gives you a x e to the x plus 2 a e to the x. Okay, now that's your y p double prime. Okay, so now you take this value, plug it in there. So what that gives you is a x e to the x plus 2 a e to the x. That's that term, y double prime, minus 5 times your y prime, which is here. That's minus 5 a x e to the x minus 10, nope, I'm looking at the wrong one, minus 5, went down too far, e to the x. And then plus 4 times y, and your y is that one, y sub p. So that's plus 4 a x e to the x. Okay, all that has to equal 8 e to the x. Oh man, that just about wore me out. Sorry about that. Let me get me another. This anemia is getting old. Okay, it's much better than it was, but it's somewhat of a pain. Okay, now let's start picking our terms. How about the terms that deal with x e to the x? Okay, that's this one, and this one, and this one. Well, let's take a look at it. Ax minus 5ax, that would be minus 4ax, plus 4ax, they add to 0. Of course, there is no x e to the x over here, so those add to 0. Fine. How about e to the x terms? Well, here we have a 2a e to the x. Here we have a minus 5a e to the x, and that must equal come on, what are you doing? That just closed out my whiteboard, and there was no reason for that. Okay, that's equal to 8 e to the x. Don't write in the e to the x, just the coefficients. 2a minus 5a equal 8. So this is minus 3a is equal to 8. So a is equal to minus 8 thirds. Okay? Now, and that's really all we have to mess with. So our total solution, our general solution, y, is equal to the complementary solution, c1 e to the 4x plus c2, arbitrary coefficients, e to the x, and then plus your particular solution, and your a here is minus 8 thirds, so that'll be minus 8 thirds x e to the x. Notice if you didn't have that x in here, then these two would have added together and that would have given you a new arbitrary coefficient and you wouldn't have had a particular solution. So that's why you have to have the extra x in there. Well, let's see how the book did it, if they got the right answer. Hopefully they did. Y sub p was the, oh, they didn't write down the general solution, they just left it at y sub p is equal to negative 8/3 x e to the x, and that's what we got. Now, let's go back to the PowerPoint, which it tried to take us there earlier. Not PowerPoint, the book. This is moving so slowly now that my computer has been nothing but weird all day long. And my wife said that there's some issues with internet strength, and she said it's not just here, all of UAB's having it. She was wondering if it had to do with what was yesterday Cyber Tuesday or something like that, and you know, it's supposed to be the Black Friday sales for all the place that were doing online shopping. I believe that's it, or one of those was a local market Monday, or I mean, I don't know, but anyway, she thought that there was still carryover from that the internet just was getting completely swamped by so many people being on it, and maybe we did. Okay. Now, one thing I didn't do was carry this a little further and just assume that the ae to the x was our particular solution, and when you did that, you wound up with 0 is equal to 8e to the x, 8e to the x, and that couldn't be, because 8's never 0 and e to the x is never 0, so that is a bad guess. Okay, so what we do is put the extra x in there, ax e to the x, and then we saw that came out to be the particular solution we got. Now, let's scroll down. Okay. Man, this is going slowly. Okay. The differences in the procedures used in examples 1 to 3 and that one in 4 suggest we consider two cases. The first case reflects the situation in examples 1 to 3. Okay, they love cases, don't they? We had 3 cases in the homogeneous. So here's our case 1. No function in the assumed particular solution is also a solution of the associated homogeneous differential equation. So if that's the case, this table 4.4.1, we illustrate some specific examples of your g of x that would be on the right hand side of your differential equation, along with the corresponding of the non-homogeneous differential equation. Sorry. Solutions. We are, of course, taking for granted that no function in the assumed particular solution y sub p is duplicated in the complementary function y sub c. Okay, that's case 2, so don't assume that. So what if your g of x was just a constant other than 0? If it's a 0, it's a homogeneous case. But what if that g of x on the right hand side was just a constant? Then the form of your particular solution would just be a, another constant. Okay, it may not be the same constant, you know, and this doesn't have to be a 1. It could be 17/3. It could be a minus pi fourths. You know, it could be anything like that. Just a constant value. Then your particular solution would just be a constant a. If it's a binomial linear polynomial, then it would be a binomial linear polynomial, okay? Two terms, an x term and a constant term. If it's any quadratic, this is a two-term quadratic. It could have been a one-term quadratic. It could have been a three-term quadratic. Your y sub p would have to be a three-term quadratic. You have to account for every term. Ax squared plus bx plus c, whether this had a x term in it, whether it had a constant term in it. If you have a quadratic, your particular solution has to have all three terms. If you had a cubic function here, even though it's missing a square term here, it doesn't matter. You would have a four-term cubic y sub p. Ax cubed plus bx squared plus cx plus e. Notice they don't use these because they use that differential operator. They don't want you getting them confused. Okay? So it keeps on growing. Whatever your form of a polynomial function here is, you have to have a polynomial function of the same degree, but every term represented. Whether you had every term represented here or not, you have to represent every term here. Okay. Then what if you had one with sine, say 4x? Nothing special about the 4x. That could have been nx or mx or anything, okay? Then you would have to have both a sine and a cosine here with the same argument, 4x or mx or nx or whatever. Same thing with cosine. If you'd only had a cosine, you can't get away with just a cosine here. You have to have a cosine and a sine. On both of those, they would look identical. Now, the 4x didn't have to be 4x. It could have been a 1/2 x. Then you would have had a 1/2 x here and a 1/2 x there. Okay? You always have to, for sines and cosines, even if they're alone over here in the g of x, you have to have both of them in the yp. Okay? And e to the 5x, or e to the any, let's call it nx, e to the nx. Then you would have to have a e to the nx. And that's all. You don't need anything else. But if you have a polynomial coefficient for that e to the nx, then you'll need a polynomial coefficient of the same order. This was a linear, so you need a linear here, and linears always come in two terms. Even if this had just been a 9x e to the 5x, you still would have needed an ax plus b e to the 5x here. Now, if you had an x squared e to the 5x here, that's a polynomial, x squared. So you'd have to have the polynomial with every term in it, ax squared plus bx plus c times e to the 5x. If you had a e to the 3x here with a sine 4x, all you need is one e to the 3x, okay? But you need both a sine and a cosine 4x. So they listed the e to the 3x twice. You could have factored it out if you wanted to, but it's just as easy to leave it in. Here they kept it factored. Here they multiplied it in. It doesn't matter. You basically need to multiply them in every case. Here, if you had an e to the 3x times a sine of 4x, you're going to need to have an e to the 3x times a cosine and a sine. I think I already said that one. Okay? If you had a 5x squared sine 4x, okay, now you have a double whammy here. This one has to be an ax squared plus bx times c times a sine 4x and times a cosine 4x. They put the cosine first, that's fine. So you have a quadratic here in front of the cosine and a different quadratic here in front of the sine. So you can't use the same one. You have to have a separate one for each of those. Okay? And then, I don't know if this is the last one or not, it's the last one on this page. Now, is that somebody else coming in? I don't think so. Let me just check. Nope, just the two of you. At least you're twice as many as we had here Monday. Okay. Here was the x. Okay, here we have three different forms: a polynomial form, an exponential form, and a cosine form. Okay, this is going to require ax plus b to begin with. You only need one e in there. Okay, e to the 3x. Okay, but you'll also need a cosine 4x and a sine 4x. Okay, so the a plus bx times e to the x cosine 4x, and then you'll need to repeat your coefficients here, but different ones. Okay, maybe I shouldn't have said repeat them, but list them again as different ones. Cx plus e to the x sine 4x. Okay, so those are your various ways of expressing that. Now, for some reason, this really messed up the writing here, didn't it? That's supposed to be trial particular solutions. There's the S. I don't know where the rest of it is. That is as messed up as I've ever seen a title, and I have no idea why. All right. So anyway, let's move on down from here. Boy, this scrolling is slow as molasses, and it's very jerky too. All right, so here's example 5. We've got 5 minutes to do example 5. It says determine the form of a particular solution for these two. It doesn't say figure out what it is, but let's determine the form. So let's go back to our whiteboard. Goodness, this is slow. Okay. Go back to the whiteboard, and I got to move y'all out of the way again. Okay. Let's clear the drawing before. Does anyone need it any longer? Okay. Now, let me get it in my lap so I can read it. Determine the form of the particular solution of this one. The A one is going to be y double prime minus 8 y prime plus 25 y is equal to 5 x cubed e to the minus x minus 7 e to the minus x. Now, I think I copied it right. All we're really interested in is the form of the particular solution. Okay. Now, as we saw in the earlier example, the last example, you always have to consider what's going on with the complementary solution. Okay? Well, if you look at this, that's going to be an m squared minus 8m plus 25. Guess what? That is not going to factor. Okay? So you will not have an e to the, e to the minus 1 is not going to be in it. It will not. E equal minus 1, m equal minus 1 will not be a solution. You can tell it wouldn't. Okay? So therefore we don't have to worry about that special case. So forget that one. Now, I would be tempted to rewrite this. Goodness, my pen is stuck. Okay, there it is. Okay. As this, 5x cubed minus 7 times e to the minus x. That looks more like the table that we just looked at. So what would be the form of your particular solution? Y sub p would be a x cubed plus b x squared, you have to account for every term here, plus c x, and they don't like to use d, so I'll go along with them and do plus e, and that would be times e to the minus x. Yeah. Okay, that would be it. Now, you could distribute that e to the minus x in and write it after every term. If you wanted to, you certainly could do that. You would have to do that to do your derivatives and stuff, so at some point you would have to do it. But they did the same thing I did. They left it as y sub p is equal to a x cubed plus bx squared plus cx plus e to the minus x. Okay? Now, actually, I sort of jumped the gun on that a little bit. I forgot about that. This part over here could have had a an e to the either 3x or minus x as your real part of a complex solution, but it didn't. So we're okay. This one happened to be the solution to that auxiliary equation was actually going to be complex with imaginary parts to it. But it still didn't turn out being either a 3 or a minus 1. Okay, so you're okay with that. Now they went on and showed the complementary solution. Let's do it, because this one is one of those that you would have to pay attention to that. Your auxiliary equation would be m squared minus 8m plus 25, and because we set that equal to 0, this will be equal to 0. Right hand side homogeneous, you know. Okay, now that you can't factor, so you use quadratic formula. M is equal to minus b, that would be 8, plus or minus the square root of b squared, which is 64, minus 4ac. 4 times 1 is 4, times 25 would be 100. And that's a minus because there's only one minus sign in there. And that's all over to a, which is just 2. Okay, and that would be 8 plus or minus the square root of negative 36 over 2, which is 8 plus or minus 6i over 2, which is 4 plus or minus 3i. What does that give you as your complementary solution? Y sub c would equal to, there's the real part, so that would be e to the 4x, the real part goes there, times c1, this is where your arbitrary coefficients go, cosine of your coefficient of the imaginary part, that's your beta, 3x plus c2 sine 3x. Certainly none of these up here had sines or cosines in it, so you don't have to worry about that. And even this e to the 4x is nothing like either your e to the minus x up here. Okay, so didn't have to sweat that at all. Well, did I copy that problem right? I think I did, yeah. Okay, now we've just gone over. Sorry about that, folks. Okay, first thing I'm going to do is we didn't get to do the B part, but it's fairly straightforward. This section had tons of examples in it. We didn't get them all done. Homework exercises here would be any of the odds 1 through 25. I think you could do any of the odds 27 through 35. We didn't do any boundary value problems, so I would say less. I don't think they had any boundary value problem in the examples either. So okay, we'll just leave it like that. Now let me, goodness, my hands are so cold. I think that's part of this anemia too. I'm going to, just a moment here if I can get my pen to show up, open, well wait, that's not where I want to go, sorry. That's not what I want, and I can't get it out of it now, so I'm going here. This is such a pain. Let me move this. Okay, well, that took care of it, didn't it? Okay, now let me go back here. Where is my cursor? It has been moving all over the place all day long. Okay. Well, we're back here again. That's where I want to be. Okay. Here's your test 3. I don't know if you can see this yet. Can you see Word opening? No, you can't. Okay. Okay. Now, here's your test 3. You can do all of these A through H under number 1. That stuff we did way back early in chapter 4. Determining whether these two functions here, f1 and f2, are linearly independent or dependent. So all you have to do is write here independent or dependent, one word or the other in these lines here. That's the first question. How many parts is that? 8 parts, 9 parts, something like that. 8 parts. So there's 8 answers right there. All right. Now in this part, we're talking about things we're doing in 4.4. Can this equation, this g of x, this is what we're doing today, can this be answered? Can this be solved when the g of x is over here, these g of x is over there, in these forms by the method of undetermined coefficients? All you have to put here is y or n in each one of these places. That's it. Okay. Now we didn't get to section 4.6. Okay. I had hoped we would. We didn't get there. So you can leave these blank, or if you want to make a guess, you can guess. If you want to read ahead and see what you can do that. If you leave them blank or get them wrong, they're not going to hurt you. If you answer them correctly, you'll get bonus. If you answer them incorrectly, it's not going to hurt you. Okay? Now, the three problems at the bottom are, there's a homogeneous differential equation, linear differential equation. Surely you can do that one. Here's another homogeneous linear differential equation. A little more involved because it's a third order differential equation. This is only second, but you can still do it. Okay? And then this is a non-homogeneous. That's the ones we've just been working on, and you should be able to do that. Okay? So you have 8 questions up here. All the answers are either independent or dependent, one or the other. You have 6 questions down here, either yes or no for all those. If you want to try these, you have 6 more, but you don't have to. And then you have 3 more down here. A relatively short test, hopefully shorter than the first 2 were, and hopefully something you can easily get done in a week. Okay? Any questions on those? So these 6 right here are the optional parts. You can either do them or not do them. They're not going to hurt you if you get them wrong or leave them blank. You get extra bonus if you get them right. Okay? So pretty good deal there. Any question?
Like is test 3 for differential equations up on one of the weeks, or is it in messages?
Okay, I haven't gotten it out there yet. Let me go on and do that for you too, since you asked. Okay. What's that? I can't hear you.
I was actually like what are the messages, but you say it wasn't in there yet.
Yeah, right. I'm going to show you where I'm going to put it. Okay. Well, I was going to show you that. Okay. Let me get to Blackboard. I thought I had it open. Okay, it's going to take me just a little bit to open it. Blackboard is such a pain in the neck. Okay. There was our invite for today's class. Let's get out of course announcements. And okay. Now, your question is, where is it going to be? I'll either put it under here, Blackboard Messages. I will put it there. No matter what else, I'll put it there. Okay. Oh, wait, you can't see this. Let me get this shared going. Right here. Okay. Can you see the opening page, the content page for Blackboard? Can you see that? So I will put it here under Messages. I don't have it there yet, but I will put it there. Okay. Now, here is the other place that I will try to put it, and let me see if I can. You see down here it says exams, midterm, and final. Well, there wasn't a midterm exam per se. You had 2 midterm exams. Those were done separately up in the weekly things. So right down here, if you open this, now I'm not using ProctorU or any of that mess, okay? And what I'll do is here under final exam, let me see if anything's here. Yes, I will be able to put it here. Now you can't see that final exam yet, but I will open it up so you can. In fact, I'll take it so it's not hidden. Yuck, y'all are in the way. We're in the way. Make it visible to students. Okay, so I will, where this little plus sign is, I will put the final exam in there. So it'll be in 2 places. It'll be under final exam. That's outside the weekly activities, under final exam, and it'll also be under Blackboard Messages. Okay? So it'll be in 2 places, wherever you want to, however is easier for you to get it. Okay? Does that answer your question? Yay or nay? In fact, I think I'll put it there right now. Add local file. Okay, why it went back to that, I have no idea. Okay. There it is, right there. Okay. And I'll get out of here. Okay. And I'll go back to Blackboard Messages. Unlike the other classes, you're going to have it there already. Okay. And okay, I've got to move y'all out of the way so I can type here. And I'm going to put the test in there, local files, and test 3, and save, and okay. So there you have it in both places. All right. And I said attached before, but I did this now. Where is test 2? I guess that's in a weekly thing. I thought I put it in both places. But y'all got test 2, didn't you? Yay or nay?
Yeah, like I already turned mine in.
Okay, yeah, I thought so. I must have only put it under that weekly activities. I meant to put it in both places.
And chapter 4 test, second test for differential equations.
Yeah, okay. The first test for chapter 1, the second test for chapter 2, and the third test is chapter 4. We skipped chapter 3. Yeah, we only have the 3 tests.
So the last test for this this last test is the final exam as well?
Yes, it is. The chapter 4 test is counting as the final exam. Right. Okay. It counts the same amount as the others. The only difference is the research paper cannot be dropped and the chapter 4 test cannot be dropped. If it helps you to drop the lower score between chapter 1 and chapter 2, I will do that. But I will not drop the research paper or the last test, the final exam, chapter 4 test. So you have to do this one, and then if it helps your average to drop the lower one of 1 or 2, then I'll do that. Okay.
So the chapter 4 test is the final exam.
Yes, the chapter 4 test is the final exam. Okay. Good deal.
So I can just submit it like in the grade section where it goes say chapter 4 test.
Okay. If I understood you, how to submit it, you can either send it to me in an email, you can send it to me under Blackboard Messages, or you can send it to me in that final exam tab on the homepage of Blackboard. Whatever is easier for you to do, get it to me one way or the other. I'll be checking all of those at various times, and just get them to me as soon as you can. Okay, good deal. Any other questions? I'll do that tomorrow when we finish class, so I'll know how, which questions to make optional and whatever. Okay?
You didn't post the test in calculus yet?
No, I just finished this class. I'm going to do the post the Cal 2 and Cal 3 test as soon as I get offline with y'all. Okay? Okay. James, your microphone's still on, by the way. Okay. All right. Okay. Any other questions? Okay. Be sure you turn your mic on if you do have a question, but you just turned it off, James. But anyway, please do your student course evaluations and get me all of your work as soon as you can, because both of you are graduating. I'll need your grades in earlier than I'll need everybody else. So get me as much as you can as soon as you can. All right. Yes. Okay. I don't know a precise answer to that, but here's where they usually do. They usually send you an email, and in the email they'll have a link and tell you how to get there and instructions of how to do it. So if there's any changes from back before we were on Banner, if Banner System has changes to it, they'll explain those in that email. I saw an email, but it was directed toward us, not toward you. So I don't know if I have the one they sent you. But have you been checking your email pretty regularly, or might you have missed it? You have. Oh, you have not. Okay, let me, while we're here, since you asked that, let me go to let's see. Let me just go to inbox, because it was fairly close to the top of my inbox, because they fairly recently, goodness gracious, all the things have come in since this morning. Okay. Nope, that's not it. Oh, I may have deleted it. Okay, let me see if I can find it. Deleted items. Okay. Goodness gracious, so much email. Okay, easier than that. Let me just search. Let me go back to inbox. Okay, search for course. This wasn't working well this morning. It's working better now. It's not listed on the course evaluations. I know I didn't permanently delete it. What would it be called? Let me see if Smart Evals works. Not there either. Goodness gracious. I didn't think I deleted it. Let me see. Incomplete grades. Well, let me do it this way. I know it came from the dean, or I think it did. No, it didn't. I know where it is. There it is. Okay. I was looking under the wrong name. I skipped right over it. Okay. Now this is sent to us, but it would have been right about these same days. Here's what it says. Students have been notified their fall 2020 surveys. That's why I wasn't getting it, because they didn't call it course evaluation, they call it surveys, are available. Please strongly encourage blah, blah, blah. Students log on using their LSCC email address. That's the one with the A number in it, not your personal email, your A number, not the one that we had back in the old system where you had your first initial, last name, and 4 digits of your old number. This is the A number email address. The password is your birth date, starting with your birth year. Mine would be 1951, plus the last 4 digits of their Social Security. Wow, I never would have guessed that. The website, and there's the website, www.smartevalves.com, blah, blah, blah. Okay, so you supposedly were sent this. I am guessing it was around November 24th. Like I said, I think that was the week of Thanksgiving, but it may have been the week before Thanksgiving. So go back and check again. It may have come from Miss Jamie Glass, but you wouldn't have seen that. It's called Online Evaluations for Lawson State. And there's a place, evaluations@smartevalves.com. There's a website. Okay, so that's how it would have come. See if you can find it. Okay. Wow. Okay.
And sometimes they send emails to my other email, but I didn't get one from there either.
Okay, did you check your A email? The one that starts with the A number?
I will.
Yeah, that's where they sent it. I bet you. Because it seems like they're doing everything on that now. Even...
They always send emails to my old one, though. That's the one I still use. But I checked the A one.
Yeah, check the A one. I bet you they're slowly going away from the old one and trying to get people to use the A one. Try the A one. I hadn't even thought of that until you asked it. I'm so glad you asked it. The only trouble is I don't get to tell the people in the first 2 classes. Of course, both of you are in the second class, but those first, so I've got to get that word out. I bet you that's where it is, under the A, your A email. Okay. Have you looked for it? Or are you looking now?
I mean, I'm a little later.
Oh, okay, good.
I logged into it before, so this is going to be my first time logging in email.
Okay, all right. Okay, good deal. I bet you that's where it is. Okay. Any other questions? Great questions. I never would have thought of that. Any other questions?
No, sir.
All right, good deal. It's been a joy and a pleasure having y'all in classes. This is my last differential equation class, maybe ever. I don't know that it is. I will be here all next week while you're turning in finals. So email me, message me on Blackboard messages. I'll be checking those things quite frequently. So if you have issues, problems, questions about the final, anything else, that's where I'll be. So get in touch with me. I think I asked last time and you said you didn't think there'd be a reason for it. I won't be sending out a Zoom invite for next week because there are no classes. They're strictly going to be final exams. So get in touch with me by email or Blackboard messages. Okay? Good deal, folks. Enjoyed having you. And I'm going to stop sharing now, if that's okay. Do you need anything off of this email any longer?
No.
Okay.
We're going to see you tomorrow.
Yeah, you'll see me tomorrow, and that's when I'll put out the final exam or the last chapter test for the linear algebra class. And that's going to be pretty short and pretty sweet too. Okay? Any other questions? All right. It's been fun, and I wish you the very best as you transfer to your next level. So do well. Let us know. You know where I live, at least for the month of January. So if you have any questions, you need any help, anything, get in touch with me there. At some point, I know I'll lose my Lawson State email address, so if you need my personal email address, I wish I could tell it to you now, but I hardly ever use it because I always use my Lawson address because I have trouble enough checking one account, much less two. So I will be transferring to that in the month of January, and so I'll know the email address by then. So if you do need to get in touch with me, get in touch with me in the month of January in my Lawson email, and if you need my personal email, I'll give it to you then. Okay?
Okay.
All right. Take care of yourselves. Be safe. The virus is terrible out there now. I mean, hospitals are filling up. UAB, they're worried that they're not going to have enough beds. It's that bad. And I just found out that one of my adjunct instructors, her son brought it home from school, and everyone in the family tested positive. And she and her husband are having the worst case. They are able to move around and take care of themselves, cook and that kind of things, but every one of them tested positive. So I have a nephew out in Texas who has been dating this woman, and he got the families together last weekend or the weekend before Thanksgiving to introduce his parents to her parents, and they're getting pretty serious. And then that night he started feeling bad. He tested the next day. He was positive. He, his girlfriend, her parents, and his parents are all now positive. It's mean stuff, baby. So don't play with it. Be safe. Please be safe. I want you to be able to go to the next level with no problems. Okay, so take care of yourselves.